Hi there, welcome back. This is Professor Hank, and in this video, we are going to take a look at an algorithm for performing a search on a doubly linked list data structure. Doubly linked list. Okay, and for this doubly linked list, we'll be looking at a pointer-based version. And as it turns out, doing a search on this particular data structure is essentially a version of a linear search. Okay, the way it's going to work is we're going to go ahead and examine each node one at a time. Okay, looking for the value that we want, that we're curious to see if it exists in the structure or not. Okay, and we're going to do this in sequence, so sequentially. Right, so as you may or may not know, the linear search is also known as a sequential search because you take a look at one item at a time, or you search through whatever list or set of values that you're interested in searching through one at a time. So how this is going to translate to a doubly linked list is it's basically going to be the same thing as doing a search on a singularly linked list, right? But if it's a doubly linked list, we've got a slightly different picture than a singularly linked list in memory. Okay, so what we're going to do is we're just going to go from node to node to node to node, right? So let's say that the value we're looking for is in this last node labeled x. Well, what's going to happen is we're going to use a temporary pointer, call it p, and we'll start at the very first node, and then we'll just ask, well, is x inside this node? If so, we'll return true. Otherwise, we'll move to the next node, right? Then we'll say, well, is x in this node? If so, then we'll return true. Otherwise, we'll go to the next node, right? And so then we'll ask again, is the value we're looking for in this node? And in this case it is, so we'll go ahead and return true, right? But let's say that instead of searching for x, we were searching for y. Well, we would have gotten this far and y is not in the list, so we would go to one more position, and that would end up with our temporary pointer p pointing at null, at nothing, right? And so then once we hit that point, we return false, indicating that we haven't found what we're looking for. Okay, so let's go ahead and take a look at the algorithm for this. So I'll go ahead and call this algorithm search. Okay, and in order for this algorithm to work, we're going to need to have the head pointer for a doubly linked list. Although, I suppose you could use the tail pointer and start your search from the end of the list and go in reverse. You could do that, and actually in certain circumstances it may be more advantageous for you to do that, right? Like if you knew for a fact that the value you were searching for was closer to the end rather than the front of the list, then it would definitely be in your best interest to start looking at the end of the list, right? But we'll just go ahead and use the head pointer, and we'll have to have a key value that we're going to search for, which I'll call k. Okay, so it's going to go like this. Let's go ahead and have a temporary pointer p. We'll initialize it with the memory address that's in the head pointer. Okay, and then what we'll do is we'll have ourselves a while loop. Okay, and so long as p is not null, okay, then what we're going to do is we're going to do our check-in, right? So initially p is going to start the head pointer. So long as p is not null, then we'll go ahead and we'll examine the contents of the node whose memory address is in p, right? So if a value inside of a field inside the node, let's say that field's name is I, if that equals the key value that we're searching for, then we found what we're looking for. There's no need to keep looking any further, right? So we can return true. We've answered the question, does there contain, or is there a node in the list that contains the value that we're looking for? Is there at least one node that contains the value we're looking for? So if we have a match, well, yeah, that's true. Okay, otherwise, if not, then what we're going to do, or what we're going to need to do, is we're going to just need to move to the next node. Okay? And eventually, either P is going to get hit null and the while loop's going to terminate, or we're going to find ourselves a match, right? When P of I equals K, and we'll return true. Now, if we get through this entire while loop and we don't find what we're looking for, right, that means there's no other logical option other than to return false, right? It means that we didn't find what we're looking for, okay? So let's go ahead and just walk through this in the abstract. Okay, so let's say that we've got ourselves a list that looks like this, right? And we'll walk through the steps of our algorithm to see if everything holds up. Okay, oops, drew that a little too far. There we go. There we go. Don't forget our tail pointer. Okay. All right, so let's say that we were looking for X, okay? Then let's go ahead and walk through this. We'd have to create ourselves, first things first in our search algorithm, we create a temporary pointer called P, and we initialize it to head, right? So we put the memory address inside of the head pointer inside of P, and then we kick into our while loop. Well, P is not null, and that's true, right? Because right now P is pointing to a valid node. Check the contents of the node. Is X, right? X is our K in this case. We're looking for X. That's the key value. Is it inside that node that P is pointing at? Nope. So therefore we skip the return, and then we go to the next statement, which is P set to P next, which means that our P pointer gets the memory address of the very next node. Go back up and have another iteration of the loop. Is P still not null? True. So then let's examine the node that P is pointing at. Does it contain our key value X? Nope. So then we kick down to the P set to P next. So then our P pointer advances to the next node. And then we ask the question, well, is P not null? True, because it's pointing at a node. Is P of I equal to K, right? So is the value inside of the node P is pointing at equal to our key value? Well, we're looking for X, so yeah, so return true. We found it, we want to return true. Indicates that the value has been found. Okay, now let's say that instead of looking for X, we were looking for Y. Okay, well, if we were looking for Y, then if P.I equals K is tested, in this case it's going to go ahead and evaluate to false because X is not Y. Remember, we're looking for Y in this second example. Well, then P advances one more position. Right, gets set to P next, and then P now points to null, right? P contains null now. So then when we go back up to the top of the while loop where it says, well, P not null, well, that's false now, so the while loop's done. Then we kick down to the return false, indicates value's not in the list. Okay, so that works great in that situation. Now, let's also test to see if our algorithm can handle a empty list. Right? So if we've got an empty list, that means that we've got a head pointer that's initialized to null and a tail pointer that's initialized to null. Right? Now I don't need to have a special case in my search algorithm for this situation, as it turns out, because watch what happens with the algorithm. Okay, so first step is initialize a temporary pointer P to H, right, to the head pointer. Well, now P is pointing at null, so now the while loop kicks in while P not null. Well, that's false. So we don't have a single iteration of that while loop, right? So then we kick down to the return false statement, and we indicate if we didn't find the value that we're looking for, which makes sense, right? Because you can't have the value you're searching for in an empty list, okay? All right, so it looks like this algorithm handles everything that we needed to handle. Let's go ahead and do some analysis. Okay, let's see if we can figure out what kind of big O we're looking at. Well, as it turns out, worst case, what do we have? Well, worst case is we have a non-empty list that doesn't have what we're looking for, right? That would mean that we would have searched this node here, we would have searched this node here, we would have searched this node here, and then we would have had to have one more iteration of that while loop to get to the null to cause the while loop to terminate. Okay, so what that means is that we're evaluating each one of those individual nodes, and so the body of this loop, of that while loop, is going to execute once for each node, right? So whenever that happens, it means that the body of this loop, or because of that, it means that the body of this loop is going to happen for n nodes, right? So if there's n nodes, we're going to have the body loop execute n times if we don't find what we're looking for. Okay, so because of that, this basically boils down to, what it boils down to is that our search is going to be a big O of n algorithm. Now, just to address a couple of other things here, just of note, right? Whenever we set that p pointer to head at the very beginning of the algorithm, doesn't matter if there's 1 node or 10 trillion nodes, that only happens once. Okay, and then that return false, that's only going to happen once. Doesn't matter how many trillions of nodes there might be in the list. The return true is only going to happen one time, no matter how many nodes there are on the list. Kind of interesting because it's part of the while loop. It's in the body of the while loop. But the thing is that this return statement only executes if the test expression above it, or the test statement above it, evaluates to true, right? So really, it's only this guy and this guy that executes for every single node in the list if we don't find what we're looking for. Okay, so that's constant. That's constant. The only thing that gets executed multiple times per node is the body of that while loop. Okay. All right. So big O of n it is. Okay. So that's everything that I wanted to talk about in this video. That covers an algorithm for performing a search on a doubly linked list. It's essentially a variation of a linear search, and it's effectively the exact same algorithm that you would use for a search on a singularly linked list. Okay, so that's everything. If you have any questions, as usual, if you're a student of mine, feel free to shoot me an email or stop by my office hours. And if you're not a student, or heck, even if you are, and you thought the video was useful, you can consider hitting that thumbs up button. Really appreciate that. And if you thought the video sucked, well, there's also a thumbs down button. That's an option as well. And if you want to, or if you feel so inclined, there's also that subscribe button you can click on. Really appreciate it. Thanks for watching, and we'll see you next time.